All right, so we are on our last section of this unit, 7.10, and we're going to break it into two parts, 7.10a and 7.10b. So let's get started with 7.10a. So essential understanding for this section is that the functions y equal e to the x and y equal natural log x are inverse functions. Just as before, this means that if a equals e to the b, then b equals the natural log of a. So again, natural log e to the x equals x, and e to the natural log x equals x. They undo each other. Okay, so we're going to start with simplifying. So the steps to simplify. One, we're going to use the power property of logarithms. The same properties for logs apply to natural log. So this is we're going to be using our property number 5. Okay. Then we're going to use either the quotient property or the product property of logarithms. So property number 4 or number 3. Okay. And then we simplify using all the skills that we have in our algebra brain and bank. Okay, so here we have where we're going to write the expression as a single natural number. So step 1 tells us to use the power property of logarithms. So step 1, we're going to use property number 5. So that means my 2 and my 6 go from being coefficients to being exponents. So we have natural log of 2 squared plus the natural log of y to the 6. Okay. Step number 2 is to either use property number 3 or property number 4. So using one or the other, because I have a plus sign, that lets me know that I'm going to use the product property, which is number 3. So I have natural log of 4 times y to the 6. And then step 3 is where I simplify. So this simply just becomes the natural log of 4y to the 6. Ta-da! All right, so over here, same thing, starting off with step 1, which is using property number 5. I can apply the 3, and that's going to give me the natural log of c to the 3rd minus the natural log of y to the 3rd. Step number 2, I'm going to apply property number 3 or number 4. Looking at what I have subtraction, so that means I'm using property number 4. So that gives me the natural log of c to the 3rd divided, I did not mean to write a division. Natural log of c to the 3rd divided by y to the 3rd. Okay, and then 3 is to simplify this. Simplify means you want to be able to use the least number of characters. So if I wanted to simplify this, I can simplify it even more by writing the natural log of c divided by y to the 3rd. One less character. Okay, all right, let's keep going. Let's get a little bigger here. So writing the expression as a single natural log. So we're just like you read a book, you work from left to right, and you're still using the same properties. So, however, when we're doing this, notice that this half, it is going to be distributed to each term. So we're really working with 3 natural log a minus 1/2 natural log b plus minus, minus 1/2 natural log c squared. Okay, so now let's get started. So number 1 is applying property number 5. So we're going to apply property number 5, apply property number 5. And that gives us natural log a to the 3rd minus natural log b to the 1/2 minus natural log c to the 1/2 times 2 times the 1/2. Okay, and we can continue from here. So now we're going to go on to step number 2. Step number 2 is where we're going to either use number 3 or number 4. Okay, noticing what we have here, we have subtraction. and subtraction. So we're going to work this from left to right. So we have the natural log of a cubed divided by the natural log of b to the half. So natural log of a cubed minus, so we're dividing b to the half, minus the natural log of c. Because 2 times 1/2 is just 1. Okay, now we're going to divide again, and we're dividing again. So here's another division. So this becomes natural log of a to the third divided by b to the half. And if I'm dividing this by c, remember that means you are multiplying by the reciprocal, so it's just c is going to end up in the denominator. And then I look, and there's really nothing to clean up here. So this is my step 3, and my answer is natural log a to the third divided by b to the half times c. Okay? On here, there isn't a number 5 or number 3. It's just one single thing. This right here, I gave it so you remember property number 2. Okay? To undo, these are undoing each other. So natural log e of e to the third, that they are quote unquote canceling one another out using property number 2 of logs. So that cancels, I'm sorry, I didn't mean to cross all the way through the 3. So that cancels out. And I'm just going to be left with 3. That's utilizing property number 2. Okay. Continuing. Here are a couple for you to practice. So go ahead and pause. Practice following the 3 steps. Remember your 3 steps are 1, use power property number 5, which is power property number 5. 2, use either product property number 3, quotient property number 4, and go from there. And then 3 is simplify. Make sure you're utilizing the least amount of characters as possible. All right, welcome back. Here are the answers to check yourself. If you did not get these answers, please let me know what I can do to help, or ask a peer. Okay, continue on. Now we're going to talk about how to solve natural log equations. So to solve natural log equations, here are our 5 steps. Step 1, we're going to simplify to get one log equation on both sides. Step 2, we're going to rewrite in exponential form using inverse operations and log properties. Step 3, we're going to use inverse operations to isolate the variable. Step 4, we're going to write the exact value and use a calculator to get an approximation. And then step 5, we're going to check our answers in the original equation. All right, so let's apply those steps. So step 1 is to simplify to one log on both sides. So step 1 is satisfied. Step 2 is to rewrite the exponential form using inverse operations of the log property. So basically, we're going to apply property number 1. So we're going to write this e to the natural log x, and what I do to one side, I have to do to the other, e squared. Okay? And then what this allows us to do is it undoes the natural log, and we're left with x equals e squared. Okay? Step 3 is to solve for x, to get x by itself. Well, we did. X is by itself. Yay! Okay? So we use inverse operations to get x by itself, and then we're going to write the exact value. So here's our exact value, x equals x squared, and we're going to use a calculator to find the approximate value. So to find the approximate value, all we're going to do is type in the calculator e squared and see what we get. And when we type e squared in the calculator, we end up with 7 and 389 thousandths. Okay? So we have our exact and our approximate. When we check our answer, we want to check with the exact. So I'm going to check with my exact. So we're going to check ourselves. So I have natural log of e squared equals 2. Is this true? Well, it turns out to be true. Why is it true? Because using property number 2, the natural log undoes the e, and I'm left with 2 equals 2. And that's a true statement, so we did it correctly. Okay, let's take it up a notch. So over here again, we want to make sure that our natural log is isolated, which it is. We have natural log x minus 3. And so it's good to go. X minus 3 squared. Step 2 is we're going to use property number 1. So we have e to the natural log of x minus 3 squared equals e to the 4. Okay? The reason why we do this again is to undo the natural log, and we're left with x minus 3 squared equals e to the 4th. Okay? We're going to take the square root of both sides, and it's going to leave us with x minus 3 equals e squared. Okay? Why is it e squared? Because it's e to the 4th. And how many groups of 2 e's can I make? I can make 2 groups of e's. All right, and then we're going to continue to, this is step 3 where we solve for x. And we're going to continue to solve for x, so our last thing to get x by itself is to add 3 to both sides. So we have that our exact value is x equals e squared plus 3. And we're going to find out our approximate value. So our approximate value would be about 10 and 389 hundredths. 89 hundredths. Okay. Step 5 is to take our exact value that we got, not our approximate. I mean, you can use the approximate and it still should give you a close answer to what you have, but if we have the exact, go ahead and plug in all as it is. So natural log of e squared plus 3 minus 3 squared. So I have e squared plus 3 minus 3 squared. And I can kind of clean this up myself. So my 3's are going to cancel out, and I'm going to put the natural log of e squared squared, which equals the natural log of e to the 4th. And the natural log using property number 2 undoes the exponential, which makes it equal to 4, which is what I need it equal to. So yes, we did it correct. Okay, one more. So again, step 1 is to simplify to 1 log equation on both sides. So this is not 1 log equation, so step 1, we're going to simplify this down. We're going to actually use property number 4 because it's being subtracted. So our 1 log equation becomes the natural log of x divided by 6 equals 0. Okay, step 2 is we're going to use property number 1 to undo our natural log. So we have the e to the natural log of x divided by 6 equals e to the 0. Okay, this undoes the natural log, and we're left with x to the 6 equals an e. Anything to the 0 power is 1. So we're left with x over 6 equals 1. Step 3 is to solve for x. What do I need to do to get x by itself? Oh, I just need to get x by itself, so I'm going to multiply both sides by 6. So that leaves me with x equals 6. And this is my exact and my approximate. If I plug this back in, checking myself, does the natural log of 6 minus the natural log of 6 equal 0? Why, yes it does. Look at that. Good job. Okay. Next example here, we have natural log of 2x plus 1 equals 6. So natural log of 2x plus 1 is already 1 log function on one side. So step 2, I'm going to use property number 1. So that gives me e to the natural log of 2x plus 1 equals e to the 6. So my natural log is undone, and I'm left with 2x plus 1 equals e to the 6. Step 3 is to solve for x. What is x? So I have to add 1, and I'm going to divide by 2. And that leaves me with x equals e to the 6 plus 1 over 2. That's my exact. I'm going to plug this in the calculator to find an approximate. So in my calculator, I'm going to create a fraction, control divide, e to the 6 plus 1 divided by 2. And we end up with a fairly large number. So we end up with approximately 202, and we'll round to the nearest thousand, 214 thousandths. Okay, so that's our exact and our approximate. We're going to plug it in and check. So again, if you want to get a 100% check, you can use the exact. This time I'm going to show you that I'm going to encourage you to use the approximate and see what happens. So if I do natural log of 202 and 214 thousandths times 2 plus 1. And I want to know, what do I get? So if I have that, I'm going to type it in. You should be typing along right with me. So we should come to the same thing at the same time. And we get 6.00049. So we get 6.005, which is 6. So yay, we did it. All right. So here are the ones for you to try in your notebook. So go ahead and pause, try the problems, and resume. All right, welcome back. Here are the answers that you should have gotten. Hopefully you did. If you have questions or comments about them, please let me know or ask a peer. Other than that, that's it.